Hi everyone, good morning all of you. Welcome back to 6th lecture on remote sensing and GIS applications for final year first semester BTech Civil Engineering students. Till now we discussed these are all concept of remote sensing, electromagnetic radiation, electromagnetic spectrum, energy interaction with atmosphere and energy interaction with earth surface, characteristics of remote sensing systems. Yesterday we discussed about some spatial resolution and radiometric resolution. Today I will cover remaining resolutions, spectral and temporal. So, first of all, just I want to revision that previous class. First one, satellite imagery. Satellite imagery consists of Earth and other planets collected by the satellite. Satellite image consists of discrete picture elements called pixels. So, this is the entire satellite image of Vijayawada. This is the Krishna river. This is the Vijayawada city. This is some hills. It's appear like this. So, means what is this? Satellite image consists of discrete picture elements. The composed of pixels. Each satellite image composed of pixels, that is called satellite image. Then what is pixel? Pixel, digital image is a two-dimensional area of pixels. Pixel always two-dimensional. Each pixel contains information about a small area on the land surface which is considered as a single object. Basically, satellite image is composed of pixels. Here each pixel represents the earth surface feature. If you observe any pixel on the satellite imagery, each pixel represents the earth surface feature. Is it may be tree or forest or water, vegetation, hilly area, anything you can see this pixel. This pixel gives the earth surface feature. Each pixel has intensity value. This is the intensity value. This value yellow color indicates the intensity value. This is xy axis. That is why it is a two-dimensional array. So, two-dimensional axis, the entire pixel gives the land surface feature. The small area covers the land surface features on the satellite imagery. So, how this pixel was produced on the satellite imagery means due to the radiation only. That is, it may be reflected radiation or emitted radiation. Whatever radiation reflected from the earth surface, it is recorded or detected on the sensor in the form of pixel. This pixel having x axis two-dimensional pixel. This pixel having brightness value, intensity value, brightness value. How the brightness value you can say, whenever the radiation is recorded in the form of x and y direction, then the pixel is formed. This pixel shows the brightness value or bright value or dark value. So, that brightness value indicates the intensity value. So, the pixel shows the intensity value. That pixel value gives the digital number. So, sensor always record the reflected energy. That reflected energy is a brightness value. Brightness value is nothing but an intensity value. Intensity value you can give the pixel value. That pixel value is represented by 0 or 1 digital numbers. So, this is the pixel value. Entire satellite image we can see 0, 1, 0 to 255 pixels. Like that the digital imaging formed. Now, we want to study about resolution. So, what is the resolution? Resolution is the minimum separated, the minimum distance between two objects that can be distinguished in the image. We want to distinguish, we want to identify the minimum distance between two objects, but here we want to identify it is brightness values or intensity values. So, we want to identify the brightness value. This is a terminology in remote sensing. We are using always gray value is equal to brightness value is equal to intensity value is equal to digital number. So, these are all equal. So, if you resolution, if you find any resolution, if you want any resolution, just you can identify the brightness value, you can separable from the satellite imagery brightness value. So, that brightness value, it is capability to identify the presence of two objects, but also their properties. So, resolution is nothing but a resolving power. Resolving power means it is capability to identify the brightness values or intensity values on the satellite image, not only objects, through brightness values, through colors, who can usually identify the objects. Then not only objects, we also provide the properties. This resolution also provide the properties. So, properties of the object. So, here what is resolution? Resolution is a resolving power. Resolving power means it is capability to identify the brightness values of the object, and also it provides the properties of the object. Why I am using a brightness value or intensity value? Why? Because sensor always record the brightness value or intensity value or gray values only. So, like that, first you have to identify the colors. So, first you have to identify the colors, then only you can identify the which object. Based on the color only you can identify the object name. First you have to identify the color of the satellite image. So, 4 types of resolutions are defined in the remote sensing system. One is spatial, second spectral, temporal, radiometric. So, what is these are all we will discuss one by one. One is spatial, spectral, radiometric, temporal resolutions. So, one is spatial. Spatial resolution, based on how the spatial resolution they are defined. Spatial means space, area. This area in space means area. Area recorded in the form of brightness value by the sensor. So, this the brightness recording, the sensor recorded the intensity value or brightness value or a gray value by the sensor. Then this gives the pixel value, then digital number. That dark gives the 0 value, bright gives the 1 value. This is a spatial resolution. Spatial resolution, these are all terminology. So, we are using, based on this terminology we can define the spatial resolution. So, spatial resolution always defined by using the pixel size of the pixel. If the size of the pixel, based on the size of the pixel, the spatial resolution high, spatial resolution low. We will I already explained to you, but that today once again I will revise to you. Then spectral resolution. What is a spectral resolution? Spatial resolution always defined based on the pixel size. Spectral resolution. Spectrum means range of frequency or wavelength. Range of frequency means band. Band is nothing but a range of frequency like this. So, this is the spectral resolution, spatial resolution. Spatial resolution, size of the pixel, spectral resolution, range of the frequency or wavelength or band. Then radiometric resolution. Radiometric resolution, radiance value or gray levels, energy levels, intensity value. The sensor record in the brightness values, gray values. It is digital number. The range of digital number of each band indicates the number of bits. Based on the number of bits, we can define the radiometric resolution. Based on the number of bits, we can define the radiometric resolution. Then temporal resolution, revisit time, based on the revisit time the temporal resolution is high or low, we will define that. These four are temporal, spectral, spatial resolutions. One is the first one, spatial resolution. I already explained, spatial means area, area means size of the pixel, pixel size of satellite image covering the earth surface. At the first time I told each pixel denotes recognize the earth surface on the feature on the ground, earth surface feature on ground. So, this is the pixel size of satellite image covering the earth surface. It is depend upon the instantaneous field of view. It is depend upon the instantaneous field of view and height of the satellite. For instantaneous field of view gives the size of the pixel. Instantaneous field of view gives the size of the pixel. I will show to you. High spatial resolution gives the more in details. So, what is instantaneous field of view? So, first of all you should know what is instantaneous field of view. This instantaneous field of view gives the pixel size. Based on the pixel size we will define the spatial resolution. So, this pixel size indicates the pixel size, inside the pixel size what is the earth surface features. So, instantaneous field of view, when the satellite passing through the flight direction, this is the flight direction, the sensors scan the earth surface like this. So, this is rotating like this, this is the sensor always rotating this end to this end. These are all ending incident radiation, these are all scanning incident radiation. So, from ending you can take the measurement from ending incident radiation, this is field of view. Field of view means the total area scanned by the sensor, the total ground area scanned by the sensor, this is the field of view. But these are all, if you see this is instantaneous field of view, this angle is instantaneous field of view. At a particular time it scanned the pixel by pixel, that is called instantaneous field of view. Instantaneous field of view gives the pixel size of the pixel. Field of view gives the this is the field of view. Here at a particular instant of time it detects the single pixel or single element, that is called at a particular instant of time it detects the single pixel is called instantaneous field of view. The field of view means it scans the at particular time at entire the ground, that is why these are all incident radiation at the edges. The angle between these edges, incident angles, incident rays is called field of view, but this scanning means instantaneous field of view. See here, this is the how much area scanned by the sensor at particular time. It is depend upon this instantaneous field of view depend upon height, and this is the height and IFOV, instantaneous field of view. So, what is the spatial resolution? Always depend upon instantaneous field of view and height. Spatial resolution always depend upon instantaneous field of view and height. For example, if you going to higher, then you will get the coarse resolution. So, if you going to larger height, then you get the you get the large area. You can view the large area. If you going to large area, if you view the large area, it is capable to identify the object is less. So, it provides the coarse resolution. For example, if you going to lower height, from the earth surface, it is ability to identify the object is more, then you will get more information. So, the spatial resolution depend upon two factors, one is height, second one is instantaneous field of view. Instantaneous field of view and height. If you go to height, larger height, then you will get the low resolution, but the covering area is very large. But if you go into lower height, it is able to identify the object is very more, but the covering area is very less. These two, height and instant field of view, depend upon spatial resolution, always depend upon these two factors. This is the best figures which identified IFOV. This is the instantaneous field of view. This is B is the pixel size. It gives the pixel size. B is the pixel size as ground resolution cell. This is ground resolution cell, also pixel size. This is the height. Based on the height, you will get the fine resolution or low resolution, coarse resolution and high resolution. So, it scans by pixel. So, this is the instantaneous field of view, always gives the pixel information, single pixel information. This pixel gives the earth surface feature information. So, this is called instantaneous field of view and spatial pixel size. Now, the spatial resolution is usually reported as a length of one side of a single pixel. So, spatial resolution always denoted by single pixel. If a sensor has a spatial resolution 20 meter, for example, sensor having spatial resolution is 20 meter, then the pixel size is how much? 20 meter. So, the pixel size and the resolution of satellite imagery both are same. If the pixel size is 20 meter, the entire satellite imagery spatial resolution is 20 meter. For example, Landsat 8 30 meter spatial resolution. In other words, an image with 30 meter spatial resolution means a single pixel represents on the ground, that is 30 meter across. So, this is the 30 meter resolution. This is satellite imagery 30 meter resolution. But that is why the single pixel size of the single pixel is 30 meter resolution. Okay. So, pixel size is 30 meter, then resolution is very low. If the size is decreasing, then the resolution is very high. I will show to you next slide. For example, if you see here 30 meter resolution, entire house will come to see in the pixel, single pixel. 30 meter resolution means this single pixel size is 30 meter. For example, this is the 5 meter resolution. So, it is single pixel display like this, the entire house is display like this. For example, 1 meter resolution. So, 30 meter resolution, you can increase the resolution 5 meter, then you can increase the resolution 1 meter, then total house will come appear like this. We will get the much information. See, this is the pixel size is very high. Higher pixel size, you will get the less information from this image. Lower pixel size, you will get the more information. See, this is the difference. As the resolution is 30 to 5 to 10, the pixel size is decreases, then the resolution is increases. Okay. I will show to you best example, another example. See, this is the, for example, if you image the 100 meter ground, playground, if you observe 100 meter playground, then it is appear like this. So, sensor also resolution 100 meter, then playground resolution playground also 100 meter, then entire playground will come to single picture. In this picture, we could not able to get any information. For if suppose if suppose you can increase the resolution from 100 meter to 10 meter, this is the 10 meter resolution. If you increase the resolution 100 meter to 10 meter, then it will scan like this. So, it will scan pixel by pixel, it will scanning. This is the sensor, this is the satellite, sensor is on board on the satellite, it is the scanning the pixel by pixel entire the playground. Then the resolution previously can 100 meter resolution, the total playground will come to one single pixel. Now, the resolution will increase to 100 meter to 10 meter resolution, then the total playground, the entire playground will come to in this way. This mean why? Because the 10 meter resolution is increases. So, 100 pixels also coming, each and every pixel will identify the small area, that is why it will appear like this. So, that is the difference between high resolution and low resolution. If the high resolution size of the pixel is difference between the low resolution. So, this is the and another example, this is a 250 kilometer, pixel size is very high, this is the pixel size is less, this pixel size is very less, that is why you will get some information from this image. This is the spatial resolution, pixel size is equal to the spatial resolution of the satellite imagery. This is the 100 meter pixel size gives the 100 meter spatial resolution of that imagery. 28 meter pixel size, this satellite imagery spatial resolution is 28 kilometer. So, this is, if you observe here, this is the different satellite image. I will compare this here. This is the entire city of this image. If you take the zoom from this image, this is the building. If you identify the building here, no problem, but what is this pillars? You see that white color lines, some pillars like that. So, if you want to do analysis, again this pillar, if you want to research, doing any research in the pillar, what is the length of the pillar, what is the size of the pillar, what is the color of the pillar, what is the width of the pillar. So, if you want to do each and every pillar, what should you do? You can take the high resolution picture, if you take the high resolution picture. So, if this is the 80 meter resolution, this is the Landsat MSS sensor satellite, this is the Landsat satellite 80 meter resolution, it appears like this. So, 80 meter to 30 meter, you can increase the resolution here 80 meter to 30 meter, then it appears like this. That small lines also appears, these are all pillars on the building. If you want to further analysis, you can do, this is also not enough to analysis of the each and individual pillars, then you can go further, increase the resolution. This is a 30 to 10 meter resolution. This is the spot satellite. Spot satellite resolution 10 meter resolution, it will appears good from compared with previous. Then 10 meter resolution to spot series to this is the Iconus series. Iconus satellite, this is the 4 meter resolution. When compared to 10 meter resolution, this 4 meter resolution is very high. This pixel size is 4 meter, resolution of the satellite, spatial resolution of the satellite is also 4 meter. So, that is a 4 meter resolution will get good from this small area. Then you can further improve, if you want to analysis further that space, that pillar, then you can increase resolution of the spatial. So, this is the spatial 1 meter resolution. This 1 meter resolution, see how it appears, the length, width, size, and color also, tone, structure, pattern, these are all you can easily analysis from this image. This is the 1 meter resolution, this is the advanced technology we are using for remote sensing. So, like that this is the very useful for analysis of all small objects also. This is the spatial resolution, the best example of analysis of spatial resolution. this is 30 meter resolution, we could not able to get any information from this spatial 30 meter. Then 15 meter resolution, also small information we can separable from water and forest. But if you see here, you can easily tides, you can easily identify the tides and rocks and soils and forest, different types of forest, inside the forest and thick forest also there, thin forest also there. So many you can identify in this feature. This is the 1 meter resolution. This is the spatial resolution. What is the difference between the different satellite sensors get having different spatial resolutions. This is the highest lowest spatial resolution is 250 to 1000 meter MODIS. Highest spatial resolution digital globe 0.3 meter resolution is 30 centimeters. This is the when goes to lowest to highest resolution. This is the spatial resolution between different satellites having different spatial resolutions. This is the if you this is the Google Earth image. This is entire city of this one of the part of the city of Agra city. See here, this is the river network. This is the Taj Mahal. So many buildings appear like this, some road network also appears like this. This is the forestry. So this is the Google Earth image. The same area you can take different resolution of another image. This is a 0.5 meter resolution. This is October 17th 2009. They are taking Geo I1 satellite. This is the same area. If you use the same area in different another satellite, this is the Iconus satellite, different area, it appears like this, same city. This is QuickBird France in the Paris city. QuickBird 0.6 meter 65 meters of resolution of QuickBird sensor. So different sensor like different spatial resolutions of then what is the spectral resolution? I already explained the spectral resolution. What is the spectrum? Spectrum is nothing but a length of the frequency, the range of the frequency, range of the wavelength or band. Band is nothing but a region of the frequency region of the electromagnetic spectrum. Frequency is nothing but the number of oscillations per 1 second. So spectral resolution describes the ability of sensor to define the fine wavelength intervals. So if the intervals wavelength, based on the wavelength we can see the band. Band is nothing but a range of the wavelength. Wavelength is nothing but a range of the frequency. The range of the frequency is nothing but a spectrum. Spectrum is equal to range of the frequency or range of the wavelength. It is equal to band. So number of spectral bands. We have visible region red, green, blue, near infrared, middle infrared, thermal infrared. Already I explained in electromagnetic radiation. So number of bands in the electromagnetic spectrum from gamma rays to X-rays, so many bands also available. But we are studying one visible region, thermal region, microwave region. In visible region we have 3 bands, red, green, blue, and thermal region near infrared, middle infrared, thermal infrared. So then the spectral bands of combination are good identify the specific ground features. This is I will explain to you later. This I will show to on images how to combine 3 bands and appears the ground features on the image. So red, green, blue, if you combine these two, then you can get one false color, true color, natural color, like that you can appear. So this is the band, this is band. These are all, red is band, green is also band, blue is also band, near infrared also band. Band is but nothing but red is 0.4 to 0. Blue is 0.4 to 0.5, like that. Green is 0.5 to 0.6, red is 0.6 to 0.7. This is the visible region. This is the spectral bands. Panachromatic 1 band, multispectral sensor having 4 bands or greater than 4 bands, and greater than 3 bands, 4 bands. Hyperspectral is the 100 of bands, 100 of so many bands. Hyperspectral image, hyper means high, spectrum means wavelength regions, frequencies, bands. Spectrum means nothing but a band. Hyper, high bands, hundreds of bands. If you see the ability of the sensor to identify the wavelength intervals. What is the spectral resolution? To identify the spectrum, to identify the bands. So, to identify the electric, based on the spectrum, we identify the earth surface features. So, it is able to identify the wavelength intervals. For example, if you see, this is the satellite imagery, spectral profile Sentinel-2 data. This is the Sentinel-2 data image. See, this is the water body, some vegetation also there. Beside the water, some vegetation is there, vegetation covering. Some if you see here, there is some soil also appear, dry soil also appear here. When the satellite incident the radiation on this, then the reflected radiation we will get to the satellite. Satellite also received the reflected radiation in the presence of the sunlight. So, that you can take the reflectance. This is the reflectance y axis, then the wavelength band, visible band, and 0.4 to 0.5, 0.5 to 0.6, 0.6 to 0.7, 0.7 to 1.5, 1.5 to 8, 8 to 10, 10 to 15, like that. These are all electromagnetic spectrum. I already explained the electromagnetic spectrum with visible region, thermal region, microwave region. See here, visible region 0.4 to 0.7. If you see green area, this is the infrared region. This infrared region gets more reflectance. Water is less reflectance. Green is more reflectance. See, green is 50, reflectance is more, and soil is very more reflectance. So, water less reflectance means whenever the radiation incident on the water body, the total radiation is absorbed by the water. That is why reflectance is very low. That is why it appears dark on the image. Then green reflectance more, higher the reflectance of green. Green is, this is the red color. This red color, it appears the infrared region. See, green, water, forest having some canopy, trees canopy. Canopy means leaves. Leaves, generally leaves in green color. When the radiation incident on the forest area, it reflects more infrared region. See, infrared radiation more. This is the infrared region. So, red region is reflected more. That is why it appears red. Vegetation appears red in the satellite imagery. Why? Because it reflects more in the infrared region, red region. This is the infrared region. Infrared region reflects more in the forest. That is why it appears. This is the infrared region, near infrared region. Visible region very less. Water is very less. This is very high. Red region is very high. It appears red. Green appears red on the image. This green appears red on the image. Why? Because violet, indigo, blue, green, yellow, orange, red sunlight incident on the forest, only red reflected more, remain rays absorbed by the trees due to the chlorophyll content in the leaves. Due to the chlorophyll content in the leaves, the infrared region is reflected more. Then soil also middle infrared. So, that is why this, if you this is observed, this is the soil some reddish color and some barren land like that. So, this is the spectral. If the spectral reflectance means when the wavelength increases, the spectrum increases, then the number of bands increases, then the resolution increases. See, list 4 bands resolution: green, red, near infrared, middle infrared. Associate 4 bands. This is, and then satellite Sentinel-2 13 bands. Some, these are all bands of blue, green, red vegetation like this. If you observe here, the number of bands is very more for hyperspectral. Hyperspectral bands are very more. That is why this is a more resolution. It consists of more resolution. The number of bands is increases, then the resolution increases. The number of wavelength regions increases, then the resolution is increases. The temporal resolution. What is temporal resolution? Temporal resolution is nothing but each satellite has its own unique revisit schedule for obtain imagery for a particular area. So, the frequency at which the sensor revisits its area is known as temporal resolution. When the sensor is frequently repeated the same area, capture the same area in repeatedly, then that is called temporal resolution. For example, if a satellite image is same area every day, every 10 days, captured in the same area every 10 days, then the temporal resolution of that satellite is 10 days. So, temporal resolution is important factor for consider the change detection studies. For example, this is sensor. This is the sun radiation incident on the earth surface. Then it reflected on the earth surface. Then it's coming the flight direction, and capture the reflected radiation, sends to the target, sends to the processing station. The antenna capturing this. So, same date and same time it will come to capturing the same area. So, that is why repeated revisiting time means same time, same date, same area, it will come to take the pictures from that area and send the pulses to the processing station. That is called so, the temporal resolution is defined as the amount of time needed to revisit and acquire the data at exact same location. It came to the exact same location and take the amount of data, capture the amount of data at the same time. This is repeat coverage consideration. This is revisit period of satellites. Revisit period of satellites means repeated image capture the separated short time intervals, separated by short time intervals. See, revisit period of satellite. How often can you make a measurement for the same area? How much time it cover the same area? 2 days, 3 days, 4 days. Depend upon the days, depend on the time. We will get the information. So, if the days is increases, then the resolution also increases. So, Landsat 16 days, it covers the 16 days. Spot is 1 to 4 days. Iconus satellite 1 to 3 days. Mode is daily continuous collection. Mode is satellite continuously collecting morning and evening. Like that, you see here. This is the rapid visit imagery. It will help for global comments. So, if you see here, this is the SkySat imagery. It shows the tanker arriving at Chinese oil terminal between 10:30 a.m. to 1:30 p.m. See, morning and evening. So, same date 10:30 and a.m. and at the same date we will capturing this. So, what is the see, if you see, this is the some you can find out multiple observations. You can find out the multiple observations. So, why? Because short intervals of time between the images to ready to understanding and characterize the rapid changes driven by human activity. Then if you see, this is the multiple observations you can find out morning and evening and so if you take the pictures morning and evening, then the resolutions will get, then we will get the so much information from this image. Due to the multiple observations, they provide the fresh and frequent data to monitoring change detection. Then if you see, this is the floods happened, this is the flood area. Some multiple changes is happened like this. So, this is not displayed like that. Some floods, this is the river, this is the settlements, some city. After flooding, it is going, the water is covered this area. by satellites, higher frequency satellites, they are seeing so much of change detection from this image. Anyway, till now we learned about spatial resolution. Spatial resolution is depend upon the size of the pixel. Spectral resolution is depend upon the range of the spectrum, range of the frequency or wavelength or band. Number of bands increases, then the spectral resolution also increases. If suppose this is the time variation, the number of time take the picture in the same area, same location, the same day, then the days increases, number of days are increases, then the temporal resolution also increases. Based on the time, we are defined this. Based on the pixel size, they are defined in the spatial resolution. Based on the bands, we are defined in the spectral resolution. Based on the brightness values, we are defined in the radiometric resolution. Radiometric resolution already explained to you. If we have time, I will explain later. So this is till now we covered the first part of first unit. Next class we will start the platforms and sensors. Okay. If you want any questions about this class, you can call me or you can send SMS through WhatsApp. I will reply you. Thank you for watching this.